Good morning, Hacksters. It is another Tuesday morning and therefore another Hackster Café. This week we're talking with Chad Sweet, the co-founder and CEO of ModalAI. Good morning, Chad. What's up?
Good morning. How are you? Thank you for having me.
I'm not bad. Thank you for joining us. Could you give us a quick rundown on what ModalAI is?
Absolutely. So we build in really short terms, we build computers for drones, but those computers are highly specialized. They are very capable. They have an incredible amount of computing power and dedicated circuitry for AI processing or deep neural network processing, and as well as we have a built-in flight controller inside of these computers. And so it's like a single board, a single computer that can do a lot of specialized tasks as well as general purpose. It runs a Debian operating system for the main CPU, and we have support for many open source tools like TensorFlow Lite and ROS and PX4 flight controller. And all of that is built in and somewhat ready to go out of the box. All the code is there ready to run and tested it and so forth, but it's very flexible so that, you know, our developers, our customers can really build a broad set of applications.
Yeah, and on your website, I noticed that you mentioned a lot about navigation, indoor and outdoor navigation. Is that sort of what people tend to focus on when building with this, or the core of what you offer with software? Are there other applications?
There's really a ton. We have customers doing all sorts of crazy things, but that indoor navigation does enable some interesting use cases. We have a customer that does greenhouse inspection drones, where the drones fly through a greenhouse taking imagery and trying to make sure that the greenhouse is running as efficiently as it possibly can.
Whoa.
And yeah, so that's like something you could do with indoor navigation, but there's really a broad set. So at the core, it's a highly capable video processor. We can ingress with our newest platform, Voxel 2, we can ingress 6 or 7 MIPI CSI imagers process all that data, and then actually actuate. So in the context of broader autonomous robots of sense, think, act, we bring all that in, and then we can actually perform all of those tasks right on the platform.
Whoa. I love the sound of this greenhouse inspection application. I would guess that they're also using onboard deep neural nets to do some processing of the video input and determine what's going on with the plants. Are they monitoring? I'd love to hear more about that. If you know.
Well, it is our customer. It's not us, but yes. So that's exactly right, though. They're doing processing on board, sending it up to the cloud, and then performing more analysis there. But it's that's like a very good example. I think, warehouse inspection, we have customers that are taking images of stuff on the shelves and aggregating that, moving that forward, and same sort of thing. So there's like really just a broad set of applications that can be enabled once you kind of uncork this capability of indoor navigation.
Yeah. There's some extra stuff that I didn't mention in your intro, which is that you're also on the board of directors for the Dronecode Foundation, and have been since 2021. And a lot of that is focused around promoting the use of drones and also promoting the growth of open source development in this space, as I understand it. And that seems to overlap well with what you're doing at ModalAI. Could you speak a little bit to how those things overlap?
Yeah, absolutely. So Dronecode is the maintainer of what's referred to as the PX4 autopilot, which is an open source flight controller and really robot actuator suite of software. We support that fully on our platforms, and it's important. Even though we offer a lot of technology, and we have, I think, half our company or so are software engineers, it's really important to us that all of it is open, because fundamentally we're trying to get our computing platform VOXL into as many robots as possible, and so having an open system, a very open development platform is more than useful. It's really necessary. And it helps us support our customers in a much more efficient fashion, as well as, we point folks to the code, as opposed to saying, oh, well, fix this bug internally or so forth, we can point folks right to the code. And it helps to be building right around the Dronecode ecosystem as well, because there's a whole lot of there's a big community there as well. There's a very nice ecosystem with folks that know how to use the platform, know how to code the platform. And so it's highly synergistic, at least to our business, to be as engaged with open source as possible.
Awesome. I feel very warm and fuzzy about open source, and I love that you're engaging so heavily with it as a company. It sounds like, as well as being like a feel-good thing, obviously, it also benefits your business in lots of ways that you've just described. That's awesome. Now, your personal history includes, most recently, I think, so ModalAI, as I understand, was sort of spun out from the Qualcomm robotics R&D department, where you were the senior director of engineering. Is that right?
That's correct. Yeah. So I think I was the first full-time person there working on robotics, probably in 2011 or so ish. I don't know. I was there for 20 years. Prior to that, I was working on computer vision as well. And so I always think of robotics as really applied computer vision. So computer vision is incredibly important, incredibly interesting, and really fun to work on. But then once you actually take that technology and have it manipulate or actuate something in the real world based on decisions you made from that data, I think that's even way more interesting, and that's really the crux of what ModalAI is at the core. And so at Qualcomm, Qualcomm still works on robotics, but our R&D group was at first actually focused on neural networks, and actually biologically inspired neural networks. I'll try not to go too deep, but biologically inspired neural networks for robotics. And that was probably a bit before its time. And so that project had started before really this what's now conventionally, what's taken off over the last 10 years of these conventional neural networks, or these convolutional neural networks. And as that took off, we decided to focus more on just Snapdragon for robotics, and Qualcomm's main processing platform is referred to as Snapdragon. And so as that built out, we created this one platform called Snapdragon Flight, and that is really where this, now what we call VOXL, after we left Qualcomm, we rebranded it a bit. I mean, we don't own the Snapdragon brand for one, so we rebranded it a bit as VOXL, or we did rebrand it as VOXL, that evolution. And we still work very closely with Qualcomm on building out the capabilities for using those processors, or their processors, in aerial robots and ground robots to some degree as well.
Oh, so yeah, I haven't seen use of ModalAI in ground robots, but that sounds really interesting. As you were talking about spinning it off into your Voxel series. And one of my favorite things about this story is that the tech that you were working on at Qualcomm ended up in the Ingenuity flyer on Mars, the first thing to fly on Mars, had your tech in it. How does that make you feel?
Well, it's incredibly exciting, and that's true. In some ways, it's kind of hard to believe it's true, but it's true. And it wasn't necessarily, or it wasn't that intentional. So certainly early on, we were building this for aerial robots, and that, I suppose, is the supreme aerial robot, where every constraint possible is there. There's no flexibility. You can't cut any corners, sort of thing. And so they needed a computing platform, and we had built at the time the most capable computing platform for aerial robots, and so they evaluated it, and we worked with them to evaluate it. There's a couple of big problems. Obviously, the travel through space is a big one, where it's being bombarded with radiation, and then there's problems when you get there with it's very cold at night, like very, very, very cold. So it's got to survive. And so they've solved an incredible number of challenges to go make that happen. But it is really cool, the platform's there, and that technology is there. And I hope, for their sake, and there's many more of those helicopters to come. I think it seems clearly that's going to be the way to go if they want to make fast progress moving across a planet, or a planet with an atmosphere.
And there's a lot of instances in which technology that's developed for space exploration, travel, settlement, etc., is sort of reflected back into Earth technology. Do you feel like you've learned things from working on this project that you brought back to your work with terrestrial robots?
Yeah, absolutely. So I think in this case, I think some of the interesting things that'll come out of that are, building something at that's fundamentally robust, and that's at the kind of the core operating system level, the core hardware software interface, and then of course on the hardware side, in this case, and which I think was to their NASA and JPL's tremendous benefit, was that they could use off-the-shelf hardware and not have to build something custom. And I think that'll be a trend that they can capitalize on significantly. But from our perspective, it's back to that. There's no corners that can be cut. So I think there'll be interesting opportunities in how do you build that system from the ground up to be very, very, very robust. If it can fly there, it can fly anywhere. With no interaction. It's 7 to 10 minutes before they get any feedback whether the flight even worked. So it's very reliability is paramount.
That's fascinating. Oh, what was my question? Oh yeah. So for these robots, you have to optimize them sort of for size, weight, and power is the sort of swap metric that I've heard of. Could you speak to things that you've done on each of those levels to make it an optimized platform?
Yes, absolutely. Sorry, there's a
little sound effect.
Background. I was trying to mute through it, but failed. So anything that needs to get off the ground, gravity is the dominant factor. It's the dominant force, and so because of that, all you care about is weight, or maybe not all, but like that's anybody who's building an aerial robot or a drone, they know the weight of every single component down to the nuts and bolts in the platform. And so, as you mentioned, swap, incredibly important. And so what we've done is, and this really falls out of using Qualcomm processors and the work that we had done at Qualcomm, where inside of your phone is a supercomputer that is performing all of these incredible tasks in your pocket at incredibly low power consumption and size. And so that integration we've really capitalized to be applied towards aerial robots. And so traditionally, especially when we began the efforts at Qualcomm, you would have a video codec board or PCB, you'd have a transmitter PCB, you'd have a flight processing PCB, you would have a GPS PCB, and you would have all of these individual components that were really already all being done in these smartphone processors. All of your phone takes video and it sends a video somewhere and it saves it and it does, and so forth. So one of the big tricks we did for swap reduction was move what's traditionally done in a traditional MCU, like an ST Micro or something. We put that flight controlling capability inside of a segregated DSP, or digital signal processor, inside of that Snapdragon chip. And so we repurposed the sensors DSP. So there's a sensors DSP in there that is for like pedestrian, like walking detection. If your phone knows how many steps you've taken, or even just lifting it up. If you have the feature turned on, or if you can lift it up, the screen pops on. There's like a little low power DSP in there that's doing background tasks that is actually isolated from the rest of the SoC from a power perspective. So it's actually robust to use because it can't be taken out as easily by the rest of the chip. And so what we did is flip it around and turn that thing up to max speed. and because we don't, when you're in the drone, you have these motors consuming 100 times more power than your chip.
Right.
You don't worry as much about running your sensors core at full speed. And so we made that run at full speed, and then turned it into a flight controller. And so this is where PX4 comes in as well. At least the first flight controller we've done is PX4, and that's a source flight controller. The first flight controller we did for Voxel 2, I should say. And so that is now running there. You don't need extra components, and if you're actually going out and building PCBs, nobody can get these MCUs that are inside of the flight controllers right now anyway. So there's like this secondary effect that we didn't really design for necessarily, but the less components not only is it wonderful for swap, wonderful for fighting gravity in aerial vehicles, but the less components makes life a lot easier on the supply chain, which is as a company that sells a lot of hardware, like the topic.
Yeah, it does proof you against that to some extent. There's a couple of things that you enjoy when you're making aerial vehicles that you're not limited to. So, for example, with the phone, you have some constraints, right? You've got, well, for one thing, like heat has got to be a problem. I'd love to hear about that. But also, like, then you don't have to put a big glass display on it. You also probably have more freedom with what shape you can make things, because it doesn't have to be a strict rectangle. Could you speak to, what's the difference? What are some differences?
So heat is absolutely a topic. So we're trying to do as much computer vision as possible. So that, of course, consumes a lot of resources, and we're trying to use, well, I should say, we're trying to enable our customers to use all of it. The more our customers use, the more they're going to get out of the platform, and the better the value proposition. So we're trying to enable as maximum use case. So, we're putting deep, we can run like 5 neural networks concurrently, for instance, using the GPU and there's an NPU. We can use both of those in parallel to get a lot out of that chip. So thereby you're generating heat. Now in an aerial vehicle, it depends on, it depends on the design a bit. A lot of our development platforms we leave open because is more airflow than you could ever generate anywhere else. You've got 4 fans
it's
running
like free fans.
Yeah, 4 fans running at 10 to 15,000 RPM. You have an incredible amount of airflow. So we can cheat on our development platforms to enable maximum utilization just because of that. It gets harder when you like our customers then, well, okay, they want to enclose it. So the tricks with that are making sure that you've got some thermally conductive surface that also, that can come out the sides, whether it's like a light aluminum bar or something like that comes out. And actually on the Voxel cam, I don't know if there's a picture of the back there, but the back is all aluminum, and it's touching all the warm components. So in that one, it's actually fully enclosed, but it's got an aluminum plate that then sits right under the propellers. And so all of the heat gets washed away, and we can run that one at full speed as long as it's flying.
And this was the one where I was confused by the perspective, and I thought that it had 3 arms instead of 4. Are there people who have built like tricopters? Is there a reason people always gravitate to 4 ones? Is it because the math is easier, or?
Yeah, the math in what's referred to as like control authority. So attitude control so the roll, pitch, yaw or on a quad rotor, or at least roll and pitch, are tremendously easy.
Seems a lot simpler.
Yeah, and so that what you get, and now you can do it with a tricopter too, but yeah, the math is a little bit harder, and the aerodynamics you have to work. But you can do it. It's people do it. It's possible. But that kind of math, or that control of roll and pitch in a quad rotor is what allows it to just sit there, right? And that's why they're popular. They're easy to fly because you can just let them sit there. In a helicopter, you can kind of do the same thing, but you're bigger, right? Those blades are a lot bigger, and it's a lot more dangerous, and it's a lot more intimidating to do anything with a quad rotor. With the smaller blades, the smaller propellers, and that ability to just sit there unperturbed is and even under high wind, like a helicopter is more susceptible to wind and so forth. Whereas a quadrotor can, like we have demos where we take a leaf blower and blow the and our quadrotor sitting there doing indoor position hold, and the quadrotor will just sit there, you know, just banked, holding its position for as long as it has battery.
I didn't know you could hover on a bank. That makes sense. Or in a banked position, rather.
Well, if it's being blown, yeah. If it's being blown by wind,
right, yeah, of course, yeah.
Yeah.
It seems like also you get the benefits like similarly in when you have a single set of rotors, they're like sort of balanced against each other in a way that the two, the four motors are.
Yep.
We have a question from Ala, community member par excellence, who says, is AI models better than using Kalman filters or similar algorithms? Are there any tips you can give to someone who works in sensor fusion research about anything new to try? Yeah, taking off on your desire to pack as many algorithms or neural nets onto one robot as possible.
Yeah, that's a great question and super insightful. I'm looking for the same thing, to be honest with you. I think there are some. Oh, what is it? I'm trying to think of the model. It's not PoseNet. PoseNet's the one where that you get people's body poses, but there's one that has a similar name. There's folks that are trying that. I haven't seen it work as well, at least in the last time I looked, which was certainly this year. But there are definitely people trying to do sensor fusion with traditional or with neural networks. And what I would say is, will it be better? What I think in almost all cases, what ends up happening is the neural networks generalize way better. And so the once you kind of get it figured out, then with the neural network, it applies to a lot more scenarios versus like the traditional geometric computer vision, where I think with the neural nets, you can spend less time on corner cases once it gets figured out. Whereas the geometric computer vision, you're kind of always tweaking for kind of new scenarios. And so the hope would be that using neural nets for sensor fusion, folks will start to make good progress there. I'd be surprised if there's not a lot of folks working on it right now, because I think it's a very, very interesting topic that is sensor fusions. It'll be forever. It'll never be done. It'll never be complete. So I think applying neural nets to it is good. But from on the flip side, for like stereo vision, there's a lot of neural nets that are doing a very good job, that seem to be applying a lot of new filters on top of traditional depth methods that make a lot cleaner depth maps, a lot more accurate. And then there's monocular depth estimation that comes out of that. So those are, I bring those up because what you would use the Kalman filter for in the sensor fusion is for like pose estimation, or where the position estimate of the robot, and then you fuse that with depth estimates, and then you build out your map. And so the sensor fusion portion is generally one of the critical components for the autonomous navigation. The depth mapping is the second critical component, and the depth mapping with neural networks is definitely, that's what all the state-of-the-art stuff is headed that way right now.
Cool. And one of the benefits you get from neural nets is that when you're training it, you don't necessarily have to, like, sometimes you can sort of feed it information and it'll kind of build its own models to predict what's going on. And you don't necessarily have to know everything that it's using to make those predictions, but also you can get these weird edge cases where it's like relying on information because you don't have necessarily as much transparency. You can get weird edge cases where, for example, something that's designed to find like a dog versus a wolf will always say, like, will run correctly until you show it like a dog that's in the mountains, and it's like, oh, that's a wolf because I decided that anything in the mountains is a wolf because that's the data you gave me. Have you run into any like weird edge cases like that?
Oh, what a good question. Well, yeah, I mean, I think just anecdotally, yes. And I don't know if they're that interesting of a story, but anecdotally, yeah, they still get confused, but generally you can like keep feeding it, you can then fix that. But it's fair to say the networks are only as good as the data they've been provided. I don't know if we have any good stories like that. but in general, yeah, there's always, I mean, we're always like trying to find people and drones and other interesting things out there. And so
Mm.
you can trick it, but then try to go back and fix it.
Yeah. I just love those stories. Chuck asks, can you discuss the development boards available and what would you suggest for an undergrad engineering course? We haven't really dug in much yet to what all you have you're developing at ModalAI. So let's take a look.
Yeah, absolutely. So so our premier platform, which is new, it's about 6 weeks old since launch, is Voxel 2. It's probably lower on that page. Yeah, there you go at the top. So that's our latest and greatest. And it has an incredible amount of computing power. I mean, it is a business card sized supercomputer, and it can fly. It can also fly. and so that would it be good for an engine? It's fairly expensive because it's using premium computing components. Like our components are expensive. It's not like we're just making up pricing. So it depends, of course, on the engineering undergraduate class, but from our direct product stuff, we have what we refer to as Flight Core. That's like a kind of like a traditional Pixhawk style flight controller that is very open source. The full kernel build, everything's open, and you can get a lot. I mean, you can certainly fly a drone, do GPS waypoints and so forth. And so, and that's kind of that's the cheapest thing we would have, which is probably more appropriate. But then for an engineering course, but we have a whole slew of things. And what we do, the approach we take on our development kits is we go from just the bare PCB, and then we build up these assemblies that end ultimately in a complete drone. And so you can see like they're actually looking right at the flight deck. That flight deck is an assembled. It has the image sensors all built in, and they're talking directly, and they're calibrated, pre-mounted, calibrated. All the config files are there. And so that when you take it out of the box, it would actually generate depth maps. It would do visual inertial odometry, and you can stick it on a drone and then go fly. I mean, it's not quite that simple, but then you can go fly and do autonomous navigation. That's the intent. So it's not just the bare PCB there. You've got the components built around it. And then we also have the full drone for that kit, which is called the M500. And that M500, which is built on kind of like a DIY kit, the S500 kit. And it's meant to be hacked, right? This is a very, very hackable drone. You're supposed to be able to take it apart and rebuild. It's kind of an onboarding drone for our customers. Now, for an undergraduate, I don't know, we do have, because we sell these very open development drones, we have a pretty significant number of our customers are university labs. And so, I mean, I think we have way over 100 university labs that buy our development drones, and they go hack them apart and they go program them and go do interesting stuff. I don't know if that's quite undergrad, because undergrads, you've got a little bit different requirements. From that perspective, just the Flight Core, which would be super well documented, fully open source, like everything is just there. You can build the code and load the whole thing. That would probably be better suited for undergrad. But we do this, for a lot of the labs, throughout the world, quite frankly, internationally, these labs are buying our development drones to go build interesting applications. That's not what they were initially intended for. They were initially intended to get our customers a working kit that they can see how it works. They can start to code, and then they can start to hack it apart and go off and, morph it into their finished product, which is also why our development drones don't look like finished products. They're not really supposed to. They're we're not trying to compete with our customers. We're saying, here's a kit that is tested and works, and we know it works. If you take it out of the box, we know it's going to fly. We know it's going to do these certain features, and then you can go build your own platform around that.
But then people are being like, no, actually, I like this one. I think I'm going to stick with this.
Yeah, well, it's certainly on the university side. Absolutely, there's absolutely this interesting business or interesting group of folks that need drones just for software development only, not for hardware development. Yeah, I guess if you want to think of it that way.
And so you have worked with, you were working on phones, you were doing 3G development engineering, you were doing robotics, you were doing computer vision. What's your background? And I'm curious about your own educational background. Are you self-taught? Did you go to university for this stuff? And I'm curious about how you view the educational landscape today and kinds of things that you would love to see that you think are available now that weren't available when you were in school, if that's what you did in school.
Yeah. So I'll tell you, it's funny. Well, yeah. So I went to engineering school and I got a computer engineering degree. And that's exactly what I've done my whole career is computer engineering, which is where hardware and software interact. And boy, at the time, I never would have thought that. I don't know what I wanted to do, I guess, but it's really funny to me that that's effectively what I've done my whole career. And now I have a company that like does that. It's hardware and software interaction. I don't know. I wouldn't have thought 25 years ago. I don't know what I would have thought I had done, but I didn't think I never thought I would stick with this long. But yeah, so I did. And then, I went to Qualcomm right after graduating and worked very heavily on drivers for chips and for 3G chips specifically. And that was really neat. It's quite an experience, like right out of school. My first year was working on satellite telephones called Global Star, which still kind of exists in some way. But then moved over to, after 1 year, into 3G, and was one of the first 30 or so folks working on a platform called EVDO, or 1x EVDO, which was really the first 3G data. So that was quite an experience, learning. It didn't exist, right? So it didn't exist before that. And so now we had to go build it, and we did successfully. And turned out to be a huge deal. It turned out to be a, world-changing idea of getting the internet in your pocket. And so I guess I was somewhat trained to go do that, though I feel like I learned an incredible amount once I started. The opportunities today, so to your point, what exists today, there is so much to self-teach this stuff.
Yeah, true.
It is unbelievable. And I just love, everything. If you want to get into embedded computing, you can go get an Arduino and just go do stuff for $20, and you can go build something, whatever you want. And it's amazing. It's amazing how difficult that was when I started my career. I mean, it would have been, I just wasn't a thing. Like, you couldn't do it. It was impossible, without millions of dollars to go invest in some thing, or you were breadboarding some crazy thing. And
I think that's a lot of ordering your own chips out of catalogs and stuff.
Yeah. Yeah, it was they're very, very difficult. But at the time, the internet did get going, and that was obviously a big opportunity. And all of a sudden, software became readily available, and software tools, the ability to code. So that now has been paired with hardware, which I think is just the biggest opportunity. And so, I believe many universities have gone this way, and even more so but you can go build stuff, and you just need to be building. And your education has to be about actually going and building things, because the opportunities are just there. You need the fundamentals, but you need to pair that really with project-based, or really results based. You end up with something that goes and does something with each course, because it's so accessible and it's so valuable.
Wonderful. I was incidentally looking up the EVDO technology that you're talking about, and I've never seen this flag on Wikipedia before, where it's like, this article is too technical for most people to understand. That's a new one for me. But the information is out there, and like you're saying, I love what you're saying about getting your hands dirty and doing project-based sort of self-teaching. There's so much for that out there, which is, of course, Hackster's whole deal. And
Absolutely.
open source, and your involvement with Dronecode and PX4 also very much geared toward that. We have ModalAI people in the house in YouTube. So if you have questions, we had a question from Hari. Is it running on a PX4 flight controller? And you already got a response back. Yes, all your other pilots, etc., come with PX4 support right out of the box. Very cool. There's another cool thing about your company, which is on here. Not this one, but you are a you base your manufacturing in the United States. I'd love to hear a bit about that, and why you made those choices, and what kinds of benefits and things it affords you. What is yeah, how does it affect your business?
Yeah, so that's right. We do build in the US. Which is an incredible amount of work. It does not make the cheapest. It's not necessarily the cheapest way to do it, but there's just, especially in the unmanned space, there's a large unmanned non-commercial or non-consumer, I should say. So like unmanned enterprise, unmanned government, that it's become effectively a requirement that you aren't sourcing your components from China. Now, when we began, it the two happened. It all happened kind of it all happened at the same time. And I don't know if it's serendipity or luck or it just worked out that way so we started building in the US, at least initially, because that was like what we knew and what we could control. And we were sourcing some of the components ourselves. So then we would start doing that. And it was somewhat easy for us to do like R&D runs and so forth. But then
Right.
that became like a thing at the same time, like something people demanded and actually wanted. And so we kept going that route. I would, when I say, I don't know if there's a master plan. It's just the way it worked out. And so we try to do everything that we possibly can in the US now, because both our customers want that. It's something we can control. And it allows us to maintain good control over the supply chain. And it's something that we're good at, quite frankly. And though it is more expensive, I don't think we're like outrageously out of scope on like, an Asia built competitor. But the customers strongly prefer it, if not require it.
Interesting. And you do, though, have customers in other countries.
Oh yeah, absolutely. And this isn't even for the unmanned aerial vehicles. Many countries around the world call out China, and for better or worse, and not wanting to import the unmanned aerial vehicles from there. It's just part of the ecosystem today. But we have customers in China too, so we're agnostic. We just happen to build the components in the US.
One last little question about that. You mentioned that you have been doing that. Is that you while you were at Qualcomm, specifically at ModalAI, or both?
Oh, building these components in the US?
Yeah.
Yeah, that's a good question. No, I was really referring to ModalAI. Though at Qualcomm, we would build it at Qualcomm because there's infinite resources to
right, yes.
manufacturing facilities and so forth. And they need it too. You need, for when you're bringing up chips, you need to be able to, every hour matters. Like you can't wait. So for anything,
right.
In the business, if you're going to sell 100 million of something, literally every hour matters. And so they, they can afford to have everything, locked up. We don't have that, but we have a very good relationship with our with the places we build, and we even run the line, like the pick and place machines and everything for like more than half of our boards. And so
makes sense.
Yeah, so we're very deep in that capability, and it helps us a lot. It's to be able to, we can move much quicker because of that, and we don't have lag. If we have a mistake, we didn't do something right, we can turn it much quicker than if we were sending it overseas and getting it back and testing it and going back and forth. So we can do it on the fly. Like we can test boards coming right off the line and know whether we've got a panic or if
Yeah, there's a lot of interesting, right now there's almost like a boom in DIY, or let's say open source sort of kit style pick and place machines. And obviously you're probably using something that's much more top of the line. But I'm curious if you've seen manufacturing technology that you're excited about that's coming out of an open source space.
So, well, we do a ton of 3D printing, which of course has strong roots and with the first MakerBots and so forth. But so that there's nothing you do in 3D printing that doesn't have a great evolution from open source. To your point on the pick and place stuff, yeah, the machines we use are high end, are very high end, but they do, and I'm going to get it wrong because it's not my area of expertise, but they're not inkjet, they're solder jet, I think. So they work kind of like a 3D printer where they lay out the solder and then the chips drop on top of them. And so instead of the traditional method where you have a stencil and the solder is wiped and swiped off, these actually effectively print out the solder onto the PCB, and then the chips go on top of that, which of course allows you to iterate much quicker. Back to like the mistake thing, like if you're you can turn, you don't have to redo stencils and so forth. You just are redoing the program. So you can see all that technology kind of coming through, and there's absolutely in every facet of manufacturing desire to be able to change it on the fly, whether it's additive with 3D printing or this solder jet with that I'm referring to on PCBs. But yeah, that I love, we'd certainly keep track of the DIY PCB etching and so forth. You think you could do kind of top side boards pretty well, but that somebody's going to get that figured out. I think there's just an incredible opportunity to be able to do quick turn PCBs that are a little bit more complex than at least what I've seen out there now, and get that into that same flow. Because if you can already program the pick and place machines to do that in that way, then if we could just get PCBs coming through that are not that don't take weeks to go fabricate.
Yeah, I suffer the same issue. I'm just doing very small sort of DIY ones, this guy, I don't know, just tiny things, and they're more for a hobby style type thing. But the same thing, it takes weeks, and I'm like, oh my god. And there's some really fascinating stuff coming down the line with biodegradable and recyclable materials. There was a paper recently about using chitin from shrimp shells to create PCB substrates that can basically be taken out of the center, and then you can easily sort of reclaim the components and things like that, which might help with supply chain issues in the future. Who knows? But just fascinating stuff in that realm. It's kind of a personal tangent there.
Absolutely. No, I'm with you. I think there's at least an opportunity there yet. I haven't seen it actually make its way into any real production, but that's going to be anytime you can, it's iteration, right? You want your hardware to act like software. Software engineers are super comfortable with 100 check-ins a day, right? You iterate your code over and over and over, and the closer you can get to that on hardware, just the faster the world is going to move in terms of technology advancement. And I think DIY will drive that, right? Because that's just going to be the foundation for a lot of this stuff. That's where big companies, you got the big fabs, you got the big pick and play. What do you care, right? You already have the money to go make it move as fast as you can. It's the DIY folks that want to figure out a way to iterate quickly, because that means it's much more tangible and much more realizable, as opposed to
absolutely
farming it out somewhere.
And then we end up with the usual DIY project problem where there's you have 18 projects going at once and nothing gets finished.
Well, that's everybody. That's every engineer, at least, I think.
Yeah, fair. So another question from Paul on LinkedIn, who asks something also kind of related to the DIY and enterprise space. In open source, there is a question of like, you get trade-offs. Like you do share a lot of your materials, and you get something from that as well. You get market saturation. You get more eyes on your stuff. You get faster development in some cases. Better documentation from the community. But yeah, Paul does ask, how do you fight software theft? And do you?
We get asked that question all the time.
Hmm.
Right now, we do not fight it at all. So
Mm.
I don't know. Maybe that leaves us wide open. But or maybe I shouldn't say that. Yeah, we have a huge team of lawyers. No, I'm just kidding. We don't. No, I mean, really, it's our biggest marketing tool. Quite frankly, our software and our code and our technical documentation, which is all wide open, and that is a big way that people find us, and they say, "Oh, look, ModalAI has solved this problem. I'm just going to go buy that stuff from them." And it's right now, that's our big top line growth enabler, is having all that open. And so, if some a onesie twosie group stole our code, I mean, that's not going to be it's just not something that we're concerned with. Now, the flip side is, if a big company did do it, they open themselves up to tremendous risk, and that it's not good. So, but we leave everything open, and figure that's I know, quite frankly, I know that's a big reason people use our products.
Nice. So we're coming around to the end here. I would love to ask you if you can share anything about what's next. I know you just came out with the Voxel 2, and that's very exciting. It's your sort of new baby. But yeah, is there anything you can speak to about what's coming up in the future? Things people should watch for?
Yeah, so we've been working on smaller reference platforms for a long time. A lot of priorities have shifted. So we will absolutely have, we have our Sentinel, which is built around Voxel 2. We will have an upgraded suite of these various sized reference platforms, hopefully down to like really, really small, like sub 200 grams. But we look at, like we have what we call our Sentinel, which is our Voxel 2. It's like an outdoor reference drone. And then we have Seeker, which is still on Voxel 1. That's like, it's intended to do indoor outdoor navigation, both, like be able to go between inside and outside. And then we have a platform we call Starling, that's the one that I've said we've, like, priority wise, we've had a hard time getting out. That'll come out. That's about a little under 250 grams. And then we're hoping to bring out one that's even smaller than that, potentially. And so we'll have an indoor platform, an indoor outdoor platform, and an outdoor platform built around Voxel 2. And then we should have a ground rover platform that we announced with Qualcomm that will come out hopefully in the very near future, and built around the RB5 platform. So we do have on the reference platforms, we've got a very, very exciting set of products coming out. And then on the hardware side, it's just infinite accessories. That's the business. It's like, this is tough stuff, and it's very hard, back to iterating quickly on hardware. It's hard for a lot of our customers. We need to offer a lot of the peripheral, image sensors and adapters and cables and components to do all sorts of stuff. And so really, we offer all of the components really needed to go build a complete aerial vehicle, except for the frame and the motors and the propellers and the battery. Everything else on the electric, the whole E-bomb, we can really help cover. So there'll be more of that, just as once enough customers, ask for the same thing, we start to spin out new stuff.
Yeah, those are really cool. You mentioned one of the ones you have coming up, a small one is called the Starling, and that suggests to me some kind of like flocking behaviors. I'm sure that is not unrelated to why you chose that name. I'm really curious what kinds of things you'd see.
Oh yeah, so actually, you're right. So we worked on it with University of Pennsylvania's GRASP lab last fall. and some time. And so we worked with them and got the design out, and I don't remember if we fully opened. The intent was to actually open source that design. I think it may have made it out there. And yeah, that's the lab. It's somewhere in there. You can see mentioned to the Starling and ModalAI. And so but that was exactly right. So they were doing small swarming aerial vehicles, and we helped them in a couple of fronts. We actually did, I think, the frame design, and because we were integrating with our electronic speed controllers, our ESCs, and we worked with them to build out that out. And so Voxel 2 was a huge effort, and it kind of delayed us actually pushing that out into production. In terms of, I mean, we had all the prototypes worked with UPenn, and they did what they said and all of that, but it was more of getting things into production so that we can build it reliably and repeatedly. Kind of kept getting pushed aside because of Voxel 2, which is a very, 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 very big effort. That's a huge effort.
And I mean, it seems to have paid off. I just saw that on your Twitter recently, you got an award for it, or for the Voxel Flight.
Yeah, that's my Twitter's probably out of date. I need to. But yeah, that was our previous generation platform, and that one's done very well, and we have customers using that. In fact, we have a lot of customers using that today, and so. But Voxel 2 enables you to build it smaller. It has like an 8-core CPU instead of a 4-core CPU. It goes from the previous generation was 1 TOPS of deep learning. Now we have 15 TOPS of deep learning. So there's definitely it's a big upgrade for sure. And getting a big part of the effort too was our SDK, what we call the Voxel SDK, getting that to work the same on both platforms. And that's all out there in the open at code.modalai.com, and you can see all the CIs running and the whole bit that we're down to we only have a couple of libraries that are different between the two platforms. So that's a great effort.
Oh yeah, look at this.
Yep.
Code.modalai.com. Very nice. So lots for people to explore if they're interested in this. We've got code.modalai.com. Lots of ways for you to get involved. You can check out the development kits. Again, modalai.com. It sounds like maybe the best place to stay tuned for future announcements, including the Starling, the ground-based rover, and other upcoming accessories and things, might be the ModalAI Twitter, which is just modal_AI, and your personal Twitter if people want to keep up with. But I know how hard it is to keep up with social stuff. That's my whole job, and I'm always behind. Thank you so much for joining us, Chad.
Thank you. My pleasure. I really appreciate it. Thank you very much, Alex.
Cheers, and thank you everyone for joining. We'll see you next week. Hack on.